Okay, let's talk a little bit about principal moments. So we can write a relationship for a moment about O, about some point O, as R cross F in general. And if you're looking at a force here, say, and you got this point O right here, well, if it's easy for you, to pick out the perpendicular distance to this force, perhaps it's given, but perhaps the geometry is easy. To this moment, I mean, to the force from the moment. Then, of course, just do this calculation. The moment about O equals d times magnitude F. As simple as that. But let's say you don't have that. However, you do have a situation like this. And perhaps you can define the y direction and the x direction here in Cartesian coordinates. Then you can figure out what your say you know what your x component vector is and your y component vector. Then it might actually be easy to figure out these distances. Here. In other words, taking our moment equation again, moment equals r cross x, r cross f, but we can break f down into the fx component and the fy component. So we could take r essentially cross fx plus r, it's not r of x, plus r cross fy. And essentially what that is, in scalar terms, is your magnitude of y times d, I guess, to o, do in the x direction, plus the magnitude of your f component times, and dOx is just really some x value, and do in the, and do in the y direction is just some y value here. So if you know what your component is, this green line here, and you know what this is, you can find your moment. If you know what this is, you can find this moment about O. And these moments, one actually happens to be going counterclockwise, the other happens to tend clockwise in the way this is drawn. That's not always the case. Then you can calculate your moments that way. Sometimes it's easier to decompose your force vector into x and y mutually perpendicular components. and find their distances, perpendicular distances to the point that you're going. This is called Varignons Theorem. And yeah, he really came up with this and got credit for something special. Too bad you weren't living back then. Okay.